We're going to be looking at end behavior of polynomials. What we're going to be doing is adding on to what we did last time, which is finding the zeros, and then we're going to find the end behaviors, and then what we're going to be graphing. So we need to understand how the end behaviors work. There's two different types of polynomials when we're talking about end behaviors. There are even degree and odd degree. An even degree would be x squared, x to the fourth, x to the sixth. Now, there's two different types of even degrees. There's negative ones and there's positive ones. So these are examples of negative ones and positive ones. So negative ones, it's going down, and positive ones, it's going up. So when we're talking about the end behavior, we're saying as x approaches negative infinity, that means as x is going to the left, then y is going down. In the same way, as x approaches infinity, that means as it goes to the right, y is going down. So that right there would be if you have a negative even degree. Now let's look at a positive even degree. Notice that the arrows are going up. So as x approaches negative infinity, that means a fancy way of saying as it goes to the left, notice y is going to infinity. And then as x approaches infinity, once again, fancy way of saying goes to the right, we see that it's going up again. Y is approaching infinity. So those are rules for even degree polynomials. Now, odd degree polynomials, notice that they're going in different directions. Even goes in the same, odds go in different directions. Example of odds would be x cubed, x to the fifth, and so on. There are negative ones, like this one right here, and there are positive ones. Now, for the negative one, what we would do is we would go as x approaches negative infinity. As it's going to the left, notice that y is going to infinity. Then we would say as x approaches infinity, as it goes to the right, notice it's going down. Y approaches negative infinity. Now, our last example would be positive odd degrees. And when we're looking at this one, notice that as x approaches negative infinity, as it goes to the left, notice it's going down. Y approaches negative infinity. As x approaches infinity, as it goes to the right, notice it's going up. Y approaches infinity. So that right there is end behavior. Now what we're going to do is we're going to basically look at the end behavior of these. The zeros are pretty easy with A and B. If you just quickly look at it, notice that it's whatever gives us a zero. So the goal with this one right here isn't really finding the zeros, even on letter B. If we're looking at this, we could find the zeros really quickly. It's whatever gives the binomial a zero. That's not our goal. Our goal is to mostly focus on the end behavior and then graph it. So when we're talking about the end behavior, we have to figure out the degree. There's three x's, that would be x to the third. They're all positive, so that would be positive x cubed. Now you could remember the rules that we just went over. Another way to go over it is to take the x to the third and plug in -1, and the -1 represents as x approaches negative infinity. When you plug a negative into x to the third, you get a negative. Y approaches negative infinity. We do the same thing with positive infinity. As x approaches infinity, if we plug in a 1, and it doesn't have to be 1, it could be any positive number. We cube it, it's still a positive. So that means y approaches infinity. And that's another way of doing it when you don't see a graph, when you're looking at an actual equation. So now what we're going to do is we're going to graph it. with the graph, we're going to put down our intercepts. So what we have is we have 0, we have 2, we have -1. Now, we're going to take our end behavior, and our first one is as x approaches -infinity. That means the far left point we're focusing on. As it's going to the left, it's going down. So that means we make the arrow go down. Now, for the second one, as x goes to infinity, that means the far right point, y is going to infinity. That means it's going up. Then what we do is we kind of make curves. So it curves like that. And that would be our graph, kind of more of a sketch, using the zeros and the end behaviors. So if we're looking at B, we're going to find our end behaviors as x approaches -infinity. Notice that there are 4 x's, so that would be x to the 4th. And if we think of this numerically, if we plug in a -1, 4 negatives make a positive, so y approaches infinity. Now for the other one, as x approaches infinity, that means if we plug in a positive, I'm going to use 1 because that's an easy one to find the fourth of. Not a fourth, but to the 4th power. Y is a positive, so y approaches infinity. That means that when we're graphing this, I'm going to go 1, 2, 3, 1, 2, 3. Looking at my points, I have 3, -3, 1, and -1. I'm going to take the -infinity, that's the far left point, and it's a positive y, so that means it's going up. I'm going to take the far right point, and then it's also going up. So I follow the dots, and that right there would give me my quick sketch. Now what we're going to do is we're going to look at solving this. There's 2 different ways of solving this. One is by factoring, and the other one is by using synthetic division. So I'm going to try to do the same thing with both of them. With this first one, the one thing that I notice is that they all have a 3 in common. So I'm going to factor out a -3. Then I continue to see, and I'm going to set it equal to 0 because I'm going to find the zeros. I see that I have an x squared in common. So I'm going to factor out an x squared, and then I get an x minus 2. See that the -4, and that's an x minus 2. And then they both have a x minus 2 in common. And then an x squared minus 4. And if I continue to factor it, what I get are 3 different answers. I get 2, 2, and -3. Sorry, -2. With this right here, I wrote this twice because when we graph this, there's a point to why I wrote it twice. Technically, you don't have to, and it would be better if you didn't. But because of what I'm going to be doing with the graph, I just want to point that out. We're going to talk about our end behavior as x approaches. I'm looking at this term right here, and I'm plugging in my -1 as x approaches -infinity. 3 negatives, and then multiplying it by -3 means that y is a positive. As x approaches infinity, that means that as I plug in a +1, That would be 3 positives and then a negative, which would mean a negative. Y approaches negative infinity. Now, one thing I'm going to add to these that I didn't add to the other ones is the y-intercept. The y-intercept is our constant value. So that means it crosses the y-axis at negative 24. It just makes our sketch a little bit more valid. When we graph this, I'm not going to be detailed. I'm just going to put a negative 24 right here just so I know where it goes through. I have a negative 2, I have a 2 and a 2 again, and then it crosses at negative 24. When I'm looking at my end behavior, when it goes to the left, it goes up. So left is up. When it goes to the right, it goes down. So right is down. Now, when there's 2 of these, the graph does something a little bit different than the previous 2. It doesn't go through the point, it only touches the point, meaning that we have the graph going through negative 2. It goes to negative 24. It comes back up. It doesn't go through the point. It touches the point and then goes down. So what it's doing is it's saying it goes up and then it goes down at 2. Whereas with negative 2, it just goes through it once. And so whenever you have an answer twice, it's touching that, it's not going through it.